do a quick check whether can you hear me? The screen
I can hear you.
Can you see the text on the screen? Can you see my photo on the corner? Just give me some emojis in the chat if you can. Let's go through some other setups just to make sure the font sizes are looking good here in my VS Code window for our demos. And the last thing we're going to check is the resolution on the Azure portal. So if you can see everything clearly, give me some emojis as well.
Yeah.
And
so yes, I can. Can you hear me?
Yep, I can.
Yeah. So I can see everything very clearly. Thank you for joining us this morning. So over to you, Yas. I'm sure you got some very interesting content to share with us on the containers and Azure. So looking forward to this session. Over to you.
Thank you. Thank you so much. Alrighty, so let's kick start. We're going to talk about containers and how many different ways there are. Obviously, I can't cover everything, but I'm going to cover as much as I can in the next hour or so around different ways you can run your workloads in a container within Azure or even outside of Azure using Microsoft technology stacks. So if you're ready, let's kick started. I'm not going to go through introduction. My name is Yas, technical trainer working for Microsoft based in Melbourne, Australia. That's all you need to know. Apart from that, everything is irrelevant. So let's kickstart. Obviously, as we go on day by day, the containers are getting more popular because of the way they are handling some of the issues that were caused by having a monolith in place or even a simple deployment of a code base which had a lot of tasks, repetitive tasks, in fact, that they could now automate everything using containers. And apart from that, some other really great capability of containers, for example, portability, you can run it anywhere. You don't have to install external tools for example, supporting different languages and frameworks. So all of those are basically adding a lot of popularity to frameworks. And as such, cloud providers such as Microsoft Azure has also stepped in from a long time ago to support quite a few different features and the ways that you can run containers in Azure. So what we're going to cover in this talk is we're going to talk about where actually do you save your container images in Azure, and then we're going to move on to some of the platform as a service offerings, and at the end we're going to cover some of the advanced scenarios. So some of the features or services in Azure, which allows you to do some really advanced deployment and orchestration in terms of having to run, let's say, hundreds of containers as part of your workload. So where do we store our images? Well, any container you want to work with, regardless of whether it's Docker or other runtimes, you're going to have some sort of an image that you can run your container from. Now, if you don't have that much exposure to containers, think of the image as your class, where, for example, in any programming languages that you have class support, think of the container image as your class. And then when you instantiate a class, you create an instance of that class, and that will be your container. So for example, you create a running container from an image, which is very similar in terms of the concept. Obviously, afterwards, you can interact with that image, which is now a container. You can send requests to that container, receive responses, etc., etc. So that's basically your application running in that container. Now, Azure has Azure Container Registry, or ACR for short, which allows you to host your images in Azure. You might be asking now, well, I have Docker Hub, so what's the point of this service here? Well, Docker Hub is sort of like a public repository that you can store your images in, and there's nothing wrong with that. You can obviously go and store your images in Docker Hub, and there are many publishers which are doing that exactly to publish their frameworks and other popular libraries. However, if you wanted to have a private image repository where you wanted to, for example, not expose that image repository to the outside world, or you wanted to have some integrations with other Azure services, such as Azure App Services, Azure Kubernetes Services, or AKS, or even, for example, Service Fabric or container apps, again, this service comes into picture, and it's a really great addition to your toolset. Apart from that, you can even take it up a notch and include, for example, Azure policy to make sure your images that are being pushed in this particular repository, private repository, are scanned for vulnerabilities or any other kind of security feature you wanted to have at your disposal. Now, this also adds some more features on top of what any other private image repository supports. For example, we have geo-replication support, where you can host your images in multiple locations. And that gives you really great support for high availability and your disaster recovery plans. It also has a really great integration with our continuous deployment tools, such as Azure DevOps or GitHub Actions that you saw earlier while I was talking about. Now, here with this particular approach, you not only have much better support for all of these additional features, but you also have a great support for speed, both in sending or uploading an image and also downloading an image. So depending on the price tier, obviously you get more speed or less speed, but at the end of the day, it is a service that you need to really think about when you're working with containers within your Azure environment. So when do we use container registry? Let's recap. We use it if you wanted to have a private image repository. We use it if you wanted to have seamless integration with other Azure services, so AKS, Azure Container Instances, App Services, Azure Batch, Service Fabric, etc., etc. We use it if you wanted to have security audits on our images, and we also have really great developer tool integration. For example, VS Code and Visual Studio both have integration with this great service that you can leverage and make your job a lot easier. So let's do a quick demo and see this in action. So obviously, if you wanted to do that, we need to create a resource group in Azure, which I've already done, just to save some time here. And all I'm doing here, all I have here is just a simple Node.js application. So there's nothing very specific to it. It's just a HTML file, which shows a bunch of menu items and a page. And I'm going to show you how this looks like in a second. And I've got this Docker file, which this basically has a simple set of instructions on what to do and how to run this app when it's run. So all I have is basically this Node.js from the Alpine version as my build. I'm copying everything from my source into the app folder inside the container, and then I'm running npm install just to have all of the dependencies that I need for my application. And at the end, I'm creating my final image. So this is what we call a multi-stage build, by the way. This is just to reduce the size of the image if you're not familiar with it. And at the end, I'm just running my server.js, which is a simple Node.js Express server. So obviously, if you wanted to run this application, I'm going to have to build this image first. So I've already done this. Let's run the image and see what this looks like. So if I wanted to just run this image now, there you go. The image is now running. So now I can come back to my browser and go to that URL. So localhost 8080, and that's my application. So there's nothing very specific to it. The point of this demo is not this app. It is just to let you know that it's really easy to have or containerize a particular application as long as you have all the available requirements and dependencies. Anyway, so now we're going to create a random name. Obviously, the name of the Azure Container Registry should be globally unique because this is available on the default domain, which is azurecr.io. So you want to have to select a really unique name for your container registry. And then you basically can create the container registry using, at the moment I'm using Azure CLI, but you could use Azure PowerShell. You could even do it in Portal or as part of your CI/CD pipeline using different tools. So it doesn't matter how you create it. There are many different ways you can create any service in Azure. I'm just using Azure CLI. So at the moment, I already have this. So if I just type this, this is my ACR name, which is a randomly generated number at the end of the ACR. And if I just run the create command, obviously I've done this before, so the resource already exists, but this just tries to update the existing resource, but the operation should be fast enough for you to have a look at what's going on. And once this is done, we have our, there you go. So we have our container registry up and running. This is the default properties of that container registry, etc., etc. Here is the login server for that container registry. So you can see here, That's why we chose that unique name. And then basically this is all the other properties of that service. And now I want to push this image that I have here in my container registry. And the great thing about Azure CLI is that it allows you to do this using this single command. Now, previously, if you wanted to do this, you're going to have to go and basically do Docker build, then do Docker tag, and then do Docker push. So these three commands were required to be able to push this image up into your container registry. But now you can see here, we only have one image, which is really cool. And it basically makes our job much easier. So if I run this now, this is going to go ahead and build our image and then pushes it up to our container registry so that we have that image available on our for later use. So let's wait for this to finish. While this is happening, by the way, if you have any questions, feel free to put it in the chat. I already have my eyes on the chat so that I can answer your questions as we go on. You don't need to wait for the end of the talk to ask your questions. So let's wait for it to finish. It's basically trying to build my image, and then there you go. So I've got my image now pushed. So if we go back to Azure portal, now I can see my registry is created here. And if I come all the way down to my repository section, I have my repo, and inside of that, I have my first image with the latest tag available for latest use. So that's how easy it is to create and push images into your Azure Container Registry. So let's move on into our next service. So now we're going to come and host our services. So let's say we want to use the same image and we're going to host it in different services. So where do we start? Well, if you don't have any background with containers in Azure, this service, Azure Container Instances, is probably the best way for you to get started. This is a service which allows you to only run one container image. Obviously, there are exceptions to that, which we cover, but this is designed to only support, for example, running a container. And it's really great because it's the fastest way you can run a container in Azure. It's a fully managed service. It's got integration with virtual networks, for example. It's got really great integration with container registry in terms of pulling the image and sending it back. So we're going to go and have a look at some of the features of this here. Now, as I said before, this is designed to run a container, a single container. However, at times you have to run multiple containers as part of your workload. Let's say you have a web application here, which is exposed on port 80, and you have also a SQL server, which is running on port 1433, but you don't want to expose this one. You only want to expose that to the outside world. So in this case, you can run these two containers in a concept which is called container group. So basically, you deploy multiple containers as part of the single deployment, and both of these containers will share basically the same physical and hardwares under the hood, which is used by the container instance. So everything about networking, all the infrastructure is shared between all of those containers that you're running, and you can run multiple, more than two basically. You can run multiple containers in a group, and you can see here that we have also virtual network integration. Obviously, virtual network integration doesn't come with the default pricing tier, but if you go upper, you definitely get that sorted as well. So when do we use container instances? What are the use cases for it? Well, if you want to run a single container, it's basically your go-to service. If you don't need integration with other services such as VNet, again, this is a great service. Obviously, you can integrate this with VNet, but if you don't need it, this is your go-to. Running multiple containers in a group to share the same infrastructure, and they will be able to interact with each other. Again, this is a great service for that as well. And let's do a demo of that quickly. I'm not sure if I have time to do all of these demos, but let's just give it a shot. I think the creation of this service is so fast that we should be able to really quickly go and do a demo of this. So let's go here. And let's come and let's say the name of the container instance doesn't need to be unique because this isn't part of the URL. So I can call this my ACI, and let me just do a lowercase here. And I want to put it in, for example, my Australia East region. And here you can see the integration with image sources. I'm going to select Azure Container Registry. Now here you can see a message here which says the admin user is not enabled for our registry. So we're going to need to go back and fix that and come back and try to create this again. Why is that? Because that is the key to connect these two services together. So if I come to my container registry and click on access keys, you can see here we have this option of enabling the admin user, which generates two passwords for us. And we could use this, and in fact, Azure will use this as well to authenticate to this container registry and basically allow other services to use it. So let's grab this. We're going to have to refresh this, unfortunately, because it doesn't detect that the admin user is enabled on this automatically. So let's wait for this to come back. There you go. I'm going to select my demo resource group, put my name in here. Australia East is good. And now this time it automatically detected that I have this available. This is my image and this is the latest tag available. So I didn't even need to fill this up. Everything is done for me. Now you can see here the OS is Linux. Obviously at the moment this is available. And in terms of the capacity of the container instance, you can customize this from 1 to 4 vCPUs and also from 1 to 16 gigabyte of memory. But if you choose a different region, you might have support for GPU as well. So depending on your region, you might have GPU support too. Here, networking, there you go. So you can, for example, leave this as public, or you can, for example, integrate this with an existing virtual network, or you could just say, no, I don't want any particular IP address to be assigned to this particular one. I'm going to leave this public for now, and let's give this a, here, this DNS name should be unique globally. So I'm going to call this, for example, AZ, let's say power community, and it should be unique enough for now. And again, the port 80 is what we had already. And in terms of the advanced settings, there's nothing else. You could set the restart policy here to be always, to be on failure or never. You can add environment variables if you wanted to here. And you can also override the default command, which is provided inside your container. So let's go ahead and create this and see how fast this service is going to come up. And once this come up, we have our workload up and running in no time. And while this is happening, anybody has any questions, let me know in the chat. By the way, this container registry and container instance, all of these services that we're going to cover today have great integration with Azure DevOps and GitHub Actions. So you can basically automate the deployment, the building, deployment, and running your containers in Azure fully automated using the CI/CD pipeline. So there's nothing wrong with that as well. So I'm going to have to wait here. This shouldn't take longer than a few minutes. All righty. Okay, there you go. So my Azure Container Instance is up and running. And if I come to this URL, I should be able to see my application. There you go. So how fast was it to just create and deploy my container to Azure using this service? Super fast, I would say. So let's talk about another service in Azure which allows you to host containers. Obviously, Azure App Services or web apps is a way for you to run web apps, API apps, and mobile apps to answer your workloads and to run your applications. However, you could leverage the same service to run containers. So you can actually host your web application or API application in a container within the web apps. Now, why would you want to do that? If you already have container instances, why would you use this service? Well, obviously, I mentioned that container instance is a very basic level service in Azure. So there are a lot of features that are missing if you are requiring some really advanced scenarios. So where does this service come in? How does App Service help you to run your containers? And what are the features that you have available for those here are just a few that I'm going to mention, but there are many, many features that are available. So auto scaling, it's the first one, which is available. So you can configure rules based on, for example, your CPU metrics, CPU percentage, memory, TCP queues, a lot of different metrics that are available to automatically scale your web applications and your containers if your workloads increases by time. You can also set this up on a scheduled basis. So you can say, I know that Fridays are probably busy. I'm going to go and scale out my, for example, web application or my container to 5 instances on Friday morning, and then tear it down back to 1 on the Friday afternoon, or even at the end of the weekend. So it's really up to you to use that, leverage this great service. We also have staging slot, or what we call a deployment slot in general, which is a really great way for you to do A/B testing. So we allow you to have multiple versions of your application running all at the same time under the same platform, so that you can route traffic between them by, for example, specify a percentage. You could say route 20% of my traffic, live traffic, to my staging and the rest to production. And if my users are happy with whatever is in the staging, if everybody's already tested that and everybody is happy, then we can rotate, or we can swap these two together, and my application becomes live. So that's also really great. And this gives you what we call a zero downtime deployment capabilities, plus no cold start. So already the site is warmed up and there's no idle time between the swaps. So really great setup for that as well. We've got authentication automatically built in using Active Directory or other OpenID Connect Auth 2.0 supported applications. So that's also really cool. We have VNet integration. So you can enable, for example, a service endpoint or a private link, which allows you to connect to your internal networks. And that's a really great opportunity as well. And the other one is if you have a hybrid connectivity. So if you have, let's say, a workload which is running on your on-premises, using this service, you can connect to it using what we call a hybrid connection. And that is basically using Azure Relay. You don't need to even open a port on your on-premises environment. The connectivity will be happening from your on-premises environment to the Azure, and then Azure will use the same connectivity to send information back to your on-premises environment. So really great set of features there. There are many, many different features, but these are just a few hand-picked ones for you to go and have a look. We also have a great feature in the web apps, which is called Deployment Center. So what does Deployment Center do for you is it allows you to run your CI/CD pipeline. Basically, this is not a fully fledged CI/CD. We're talking about a mini CI/CD pipeline, but you can definitely leverage that and integrate it with GitHub Actions, or integrate it with Azure DevOps or private repositories, or even you can automate a zip deployment, for example. So these are all up to you what you want to do. We'll have a look at the demo of this shortly, so bear with me in a second. But this is really great because it allows you to not only have your fully CI/CD pipeline in place, but you can also link your CI/CD pipeline to your staging slot. Instead of directly pushing to production and disturbing users, you could push it to staging, go and verify everything works, and then swap these two together so that everybody is happy, there's no downtime, all the users are live using your applications while your CI/CD pipeline is running under the hood. So everything is great using these different services. So some of the use cases when we use this, well, obviously, if you want to host containerized web apps on Azure, this is a great feature. If you need auto scaling, load balance, or basically automatic load balancing between multiple instances, again, this service is really cool. Deploy in seconds. You can use the deployment center to integrate it with Azure DevOps, GitHub, Container Registry, Docker Hub, etc., etc. And you also have high availability. So this service comes with really great SLA. So you have high availability available, and also App Insights and Analytics integration, which is, again, another great addition to this service. So App Insights is basically part of the Azure Monitor solutions, where it allows you to not just monitor your server, which is running your application, but also whatever is happening inside your application. So that's also really cool. So let's again do a quick demo. I'm going to go through the portal again for this demo. And again, we're going to see how quick it is to create this particular service. So I'm going to call here click create web app. So that's one of the popular products. So when you need to search for it, I'm going to select my resource group and a name which should be unique. So let's call this again AZ Power Com should be unique enough. And this time, instead of using my code, which is the default publishing version, I don't want to publish code into this. I want to publish a Docker container. So how do we do that? Well, obviously, what type of operating system do you need? So I'm going to say, I'm going to use a Linux environment, and I'm going to select my Australia East region because that's where I'm located at the moment. The Linux App Service plan, because I don't have anything, this will create a new one for me. If I wanted to select or change the name of it, I would just select that and change the name. The sizing, well, obviously, web apps come with a lot of different sizing that you need to be aware of, and the pricing will be different for each of these, and the capabilities will also be different. Again, the point of this talk is not to go through all of these details, but I'm just going to show you that you have a really cool set of features here. So you have custom domain support, TLS, auto scaling up to 20 instances. You have staging slots, up to 20 staging slots, automatic backups of not just your application, but also your SQL Server data. So we also back up your data from your SQL Server or MySQL if you're hosting those in Azure as well, along with your application. So you have a point-in-time recovery of your application state. And you also have traffic manager support. So what I'm going to do here, I'm going to go back down to standard. I don't want to do a premium. And here I have to go and configure my Docker. Again, I can do a single Docker or I could do Docker Compose. At the moment, I will do a single Docker. And here I want to select my container registry. Again, this will pre-fill all the information for me. I don't want to provide any startup command to this. So I'm going to go and, for example, here you could see that because we chose a Linux environment, it's basically saying that you have limited support for that, but I can enable this anyway and go and create this service. So let's wait for this to finish again. This should similarly take the same amount of time that it took to create that container instances. So really quick deployment and running the container again. So compare this with running a VM, so creating a VM, installing your Docker, for example, environment inside that VM, and basically you could then you have to set up your CI/CD pipeline to deploy stuff into the VM, etc., etc. So there's a question while we are waiting. There's a question in the chat. Is it possible to deploy ERP system to container? For example, Microsoft Dynamics 365 supply chain management. Well, I would say it is. Nothing is impossible. Is that, however, you need to ask yourself, why would you want to do that? Because sometimes running everything like your application in a container will limit you in a bit more than if you were to run that in a normal environment. So I don't know the use case of your question. I would obviously do not recommend running those type of really great services, which are basically software as a solution, not just a regular application. But again, nothing is impossible. So you can definitely containerize your entire application. But the container size is going to be huge, and you have a lot to take care of when it comes to running your workloads. So there you go. My application is running. Everything is good to go, and I have my system automatically set up. So here, I wanted to show you the deployment center really quick because we are talking about obviously DevOps for majority of the day. And here is my automatic setup. So anytime that I push a new image into this, this is going to automatically update my application from that latest tag. If I didn't choose the latest tag, then this wouldn't be automatic. It would be manual. I can also enable this manually here as well to have this continuous deployment of my latest tag available. So there you go. This is my deployment center. I will have the same thing for my publishing code. If I wanted to publish code into this service, I could just use the same, and my container types or my source type will be different. So I would have, for example, Azure GitHub Actions, Azure DevOps, etc., etc. So there you go. This is all set up, and it was just 1 or 2 minutes for that service to come up and run my container, which is again a really impressive results. Now, let's talk about another service. Container apps is our latest and greatest addition to our containerization platform family. Again, this is a platform as a service environment. And think of this as, for example, AKS as a service, because this is literally running Kubernetes under the hood, but it abstracts all of those different, for example, complexities and the setup that you have to perform when you're creating your Kubernetes cluster. So when do we use this service? Well, some of the example scenarios for this great service is if you wanted to have, for example, public API endpoints, and you have, again, multiple revisions of your API, and you wanted to route traffic between multiple containers while you're running your application. Again, this is a great service, similar to what we had for deployment slots in Azure Web Apps. However, this is not designed to run your, for example, web application per se. It's more to do with APIs and sort of like background processing, sort of event-driven solution systems. If you want to run long-running background tasks, again, this is a great service because it automatically scales your workload into many different instances of your containers. So you have you can use, for example, sort of like a divide and conquer. Let's say you want to process a lot of data. You can divide that data into smaller bits and pieces and then have your container apps and, for example, scale out super large so that you can process all of those data in a concurrent manner. If you wanted to do event-driven solutions, for example, if you wanted to trigger your container whenever something happens in Azure, so let's say a queue, a message was pushed in a queue or something like that, again, this is a great service that you can leverage. And at the end, running mock services obviously is a given when you're working with these type of services, and specifically when services are hosted on top of your or any Kubernetes cluster. Again, mock services comes into picture. And because it's got a great orchestration, which is automatically done for you, this is basically sitting on an autopilot. So when you set up your stuff, everything is smoothly running, and you all need to work about configuration, not how to deploy and think of those stuff. And it also has Dapper integration. So basically really great to integrate your solutions with Dapper and have that available. Again, there are many autoscalers available with this. In fact, the majority of the Kida autoscalers are already supported by this service. There's a question from Amit. Does it require any special considerations for stateful applications? Obviously, if you have a stateful application, you're going to have to think about persistent storage, but we have this particular service has good integrations with, for example, Azure Storage, if you want to have some sort of a persistent storage for your containers, or even if you wanted to use another sort of type of storage. So for example, a queue or a blob storage, or I don't know, a file storage, you mounted it as a volume inside your container. So those are additional to this service. You basically are optional features that you can add on top. Very similar to how you do with AKS as well. So really great set of integrations for that too. Now let's talk about another service, which is again similar to what we discussed, but this time it is dedicated for running background tasks. So if you have worked with Azure Batch before, you know that this particular service is designed to run multiple background processes on a dedicated compute platform. And Batch Shipyard is an add-on. It's a component which gets added on top of Azure Batch, which allows you to run those background processes, but this time in a container. So really great setup between these two, or in addition to the Azure Batch, which allows you to run, again, containers. And this, again, has those concepts of auto scaling, running a lot of background processes in different container instances that are running under the hood, and supporting some of that background processing workload. Now, this also has great integration with, for example, Grafana. It's got great integration with some of the other monitoring tools that are available. So here is the dashboard of Grafana dashboard, which is set on top of your Azure Batch Shipyard. You can see here at a glance, you can see the CPU percentage, the memory usage, how is the file system used, network traffic, total memory, nodes, how many nodes are running, how many cores are basically used at any particular point in time. So really great monitoring or addition to the monitoring of your background process information using this service. So when do we use Azure Batch and Batch Shipyard? Well, if you wanted to do big data workloads, we could definitely use this service. It's designed to support those type of big data workloads. If you wanted to generate reports, for example, again, this is a great service. It allows you to generate reports on a scheduled basis, on a timer, whatever. Long-running tasks, generally speaking, if you have an application, if you have a web application or an API application, you really are not expecting those to perform long-running tasks. And this is exactly where this service comes in. Similar to this was Container Apps. So Container Apps also supports running long-running tasks inside a container. If you have CPU-intensive process, so you want to scale up really, really large. So let's say you wanted to run hundreds of instances and your background process on those instances. Again, this is a great service for those type of situations. I'm going to see, okay, there's no question here. So let's talk about our next service, which is Azure Service Fabric. Now, why did I why do I want to talk about this before going through AKS? Because obviously AKS is one of the flagship services which allows you to run multiple containers and orchestrates those really great. However, if you are coming from your hybrid situation, so again, if you have a hybrid environment, if you're migrating to Azure and not all your workloads are already migrated, or if you have mixed workloads, so for example, part of your workloads on your on-premises, part in Azure, or even if you have an Azure Service Fabric already running on your on-premises infrastructure, for example, on Azure, for example, you could leverage, for example, multiple different features that allows you to run this service on your on-premises environment on your own servers. So again, this is a great addition to those as well. Now, some of the features that makes this service really great is that previously Service Fabric was designed to run .NET applications. All right, so if you wanted to run this run microservices that were written in .NET, this was a great service. However, since we've added more support of other languages and also containers, again, makes this service a really ideal scenario for running those type of mixed workloads. So let's see some of the features that this particular feature supports. So lifecycle management, obviously the lifecycle of your containers from creation, from, for example, auto healing. So when your container fails, how does it come back up and running? What type of data is lost? What type of data can you restore? All of those have been automated using this service. Obviously, with this comes greater configuration. So you need to be able to configure all of this. So there is a bit of a configuration overhead on top, but again, with bigger responsibility, with bigger services comes bigger responsibility as well. You have always on availability. There's a question in the chat. I'm going to come back to this in a bit later. I don't know your name because your name is sort of like a bunch of characters and numbers. So I will get back to your question in a second. You have always on availability if you wanted to have, for example, multiple instances of these running at the same time, and you have those type of disaster recovery high availability solutions in place. Again, this service comes into rescue. Orchestration is done in a central place, whether you run your workloads completely on your own premises or whether you run it in a mixed environment. So for example, on your own premises and Azure, or whether you run it completely in Azure. Again, all of those can be orchestrated using this service. Programming models, again, we have added more support since the olden days. Now we have Java support, for example, we have container supports, which basically means you can run anything within your Service Fabric mesh. Health and monitoring, again, is a really great feature where it allows you to monitor what type of workloads do you have, how are they running, which workloads, for example, have issues, any particular errors or warnings are going to be shown in that health and monitoring section as well. DevOps and tooling obviously is a given, similar to all the other services that we've provided so far. And again, the most fascinating or most interesting feature of all of these platform as a service offerings is the auto scaling. So it can scale out to really large number of nodes and instances running all at the same time. Obviously, if you are running this on your on-premises environment, it depends on your physical infrastructure. So the auto scaling will be limited by your physical infrastructure. Okay, so here is a sort of like a high level overview of how or how this particular service looks like when you've deployed it. So you can have, for example, load balancer in the front to route traffic to your receiver. So receiver could be a web application, could be an API application. You also can have front-end node types where they're responsible to receiving information or requests from outside of your cluster. And also you can have backend node types. So these are all the backend nodes that are either answering the request from the front end or performing some sort of a event-driven solution, let's say getting triggered by a queue or messaging queue or something like that, or even simply running background process for you. So all of these are available. Again, you can connect freely with all the other Azure services, specifically with Cosmos DB, SQL Server, Azure SQL databases, managed instances. All of those are available for you to leverage as part of your storage solutions. But at the end of the day, everything is within the virtual network. So even if you deploy this in Azure, it's going to be inside a virtual network. So everything that you wanted to do in terms of external access to your nodes and cluster is going to be explicit. So you're going to have to mention that. Apart from that, it also has great integration with Azure API management. So again, you can limit or you can control your ingress data with the Azure API management on top of your front-end node types, whether they are APIs or whatever. So really, really great service in terms of running. And again, the integration with Azure Key Vault, Azure Monitor, pipelines, both in GitHub Actions and Azure DevOps makes it, again, ideal scenario for your CI/CD pipeline. So let's talk about the last question that I skipped. What is the use of Azure Relay? Well, again, this is not part of this particular talk, but just quickly, if you wanted to, let's say, talk about what it is. Let me actually do a bit of a whiteboarding here. So let's say you have this Azure environment here. So this is your Azure, for example, web app. And excuse me for I'm not really good at writing with my mouse. So Azure Relay allows you to create a connectivity between your Azure and your on-premises. So let's say this is your on-premises environment and you have a VM here running. And generally speaking, if you wanted to allow traffic from Azure to your on-premises environment, you needed to open up a port, a connection to this particular environment. Versus with Azure Relay, generally the mechanism is that the connectivity is done from inside out. So you basically establish a connectivity between your on-premises and your Azure, and that doesn't require any porting because you already have basically outgoing rather than incoming. And then the same connectivity is used to send data back to your on-premises environment. And again, this is not overview of Azure Relay or what it is. This is just an example so that you know when it is used. So what are the use cases of the Service Fabric Mesh? Well, obviously, if you wanted to do IIS lift and shift, this is a great service. Let's say you have a bunch of applications running on IIS on your on-premises environment and you wanted to bring them in Azure, you could use this service to slowly migrate all your workloads into Azure. And then once you're in Azure, you can then use any service you want. You can use AKS, you could continue keeping Service Fabric, you could use any other service that you have at your disposal. If you wanted to mix containers and Service Fabric microservices, so let's say, again, as I mentioned, if you have a Service Fabric deployed, if you have multiple microservices running, but you wanted to add more workloads into the mix, but you wanted to run them on a container. Again, this service allows you to fix that problem as well. If you wanted to reduce the impact of noisy neighbors, so again, there are some nodes sometimes that basically broadcast. They do a lot of noise. They publish a lot of noise. If you wanted to reduce the impact of those and keep your connectivity between different nodes in check, this is a great service for that as well. Now we come to the flagship of orchestration. So in terms of orchestration, Azure Kubernetes Services is basically on top of the Kubernetes, which is open source, and we have created our own flavor. Again, similar to Azure Container Registry. Why did we do that? Because we wanted to allow integration with majority of the Azure services. So let's have a look at an example of deployment to this particular service. Well, obviously you have your CI/CD pipeline, you're creating your Docker images, you're storing those in a container registry, and you can use the Azure policy to enforce that any particular image that is being pushed into that should be scanned against vulnerabilities. And then you can enforce that so that nobody can deploy to your AKS unless that check or that verification is passed. So you can do a compliance check on all the images that basically are having no vulnerability whatsoever, and only allow those to be pushed to your AKS cluster. Again, you can see how and why we have created our own flavor of Kubernetes to run in Azure. Apart from that, it's a managed service. It has a lot of features available for you. It's got auto scaling. It's got support for running both Windows and Linux clusters. You could also run them side by side if you wanted to. You could scale up to hundreds of instances of, for example, nodes that you can deploy into this service. It's got support for more than 42 regions and counting. So I think this is now wrong. I need to update this number. It's gone up since the last time I did this talk. So really great sort of support for different regions in Azure. And again, it supports availability zones as well. So if you wanted to run your cluster or multiple versions of your cluster in different zones to be protected against, for example, a natural disaster, a zone failure, flooding, fire, whatever it might be, again, that's a great way for you to go and leverage. And in fact, you can run your containers across multiple environments. So you can run basically your Kubernetes on IoT edge devices. You could run it on your on-premises environment and public cloud. And I'll tell you how to do this in a second. So what are the use cases if you wanted to use AKS? When do we use AKS? Well, obviously, if you want to lift and shift to our orchestration platform, and there's nothing, for example, like iOS involved or nothing that prevents you from running your services on a platform as a service in Azure, then again, AKS is a service to leverage. Simplifying the configuration. So again, Service Fabric Mesh is a great service. It's fantastic, but it's got a lot of complexities in terms of configuration management. Now we have abstracted a lot of those within these AKS clusters. So you basically tell us what you want to run and we run it for you and we take care of everything else. When we do the demo, you'll see how easy it is to use this service. Bringing DevOps and Kubernetes together, again, similarly, integration with GitHub Actions and Azure DevOps, all of those are in place. And ease of scaling is, again, a great service. Not only scaling between nodes, but you can also leverage what we call a virtual nodes. And that brings the ACI into the picture. So if you don't have enough nodes in your AKS cluster, and you've basically run out of capacity, you can configure an ACI, and the Azure Kubernetes Service will use that to bring more containers into your workloads and scale out using that service. So that's what we call a virtual node scaling. Data streaming, again, if you want to stream data into multiple platforms, again, this is a great service for you because it's got integration with multiple different services in Azure, makes it ideal for that situation. So let's go and do a quick demo. Obviously, this would take a bit of time to go and get deployed. But what I've done is I've already created this AKS cluster on my environment. So this is already up and running, but it doesn't have any workloads. So if I come to workloads, there's nothing running on this. These are all the defaults. So for example, the core DNS, the autoscaler, metric server, the monitoring agent, etc., etc. So what I want to do now, I want to deploy two containers into this one. One is a front end and the other one is a back end, which is basically hosting a Redis cache. So let's go and do that. So I'm going to use Cloud Shell to deploy my Kubernetes cluster, simply because my Kubernetes cluster or basically my local environment, I didn't want to install, what's going on here? Okay, that's better. I didn't want to install the kube controller, the CLI, all of that on my local environment. Obviously, I've installed those. I just wanted to showcase this to you as well. So Azure Cloud Shell is a terminal which is coming, or which basically has a lot of tools pre-configured. So you can run bash or PowerShell commands right in your browser without the need to install any tool. So all Azure CLI is installed, Azure PowerShell, Kube Controller, the Kubernetes CLI, all of these are already installed. So let's wait for this to come up. How are we doing with time? 7 minutes left, so hopefully we can wrap this up quickly. If this took a bit longer, there you go. So I'm going to go into my AKS folder, and the first thing I'm going to do here is authenticate to my cluster. So AZ AKS get credentials and pass in the resource group and pass in the name. Now what this does is basically authenticates to this Kubernetes cluster and merges that to our authentication context. So from here on, any command I'm going to send with my Kubernetes CLI, it's going to be routed to this AKS cluster. So let's say I want to say kube CTL get nodes. I want to see how many nodes I have running in this cluster. And it should return 1 because I just created a 1 node cluster just for the sake of speed. Now, while this is happening, let me show you what I have and what we want to deploy to this. Obviously, there are multiple ways you can deploy. You can use Helm charts, but I'm just using the YAML specification for it. So what do we have here? We have two applications. We have a front-end application. We have a back-end application, which is running a Redis cache. Here is the Bitnami Redis cache image. And we also have a front-end, which is running another image, which is our front-end voting application that we're going to have a look. This is exposed on port 80. So this is exposed outside of the cluster. And you can see here the type is load balancer. So it gets a public IP address. The other one doesn't have a type, which means that that's a cluster IP. It only gets a private IP address. But these two can talk to each other without any problem. And we're going to deploy this into our AKS cluster. And you can see here that you have also VS Code available in your Cloud Shell, which is super cool as well. So let's wait for this again to come back. There's a question, there you go. So this came back. There's a question in the chat. Regarding Azure Batch, can this be HTTP trigger enabled like Azure Function? Azure Batch, I believe so. I'm not quite sure, but I believe so. I'll let you know. I'll let you know in a second. Just give me a second. Okay. So here I want to just deploy my nodes. So kube controller apply -f, and we're going to pass in the file that we just had a look. And this is going to go and deploy my resources. And that's it. That's all there is to it for deploying these two applications. So if I come back here and refresh, you can see these two are getting created. So it's going to take a bit of a time for this to come up. But once it's up and running, then we have a lot of, or basically these two available. While this is happening, just to save some time, let's go and cover the last two services and we should be good to go. So Azure Arc is not a service to run container per se, but is a service which allows you to monitor and manage your multi-cloud solutions. So here you can see that you have the ability to run your containers on your edge devices, on your on-premises, or even multi-cloud, and all of those can be managed using this great service. So definitely check this service if you have those sort of setups. Some of the use cases for this: managing multiple sites running Kubernetes through a centralized management system. It's a great service. Ensuring the consistent deployment and configuration of nodes and clusters. Again. And also, if you have any regulatory requirements or whatever that might be enforced by government or other agencies on your projects. Now, remember, I told you that you can run Azure Kubernetes services on your on-premises as well, and also in other cloud providers. That is done through Azure AKS engine. So we have created our own flavor of AKS, but we have also open sourced our own flavor. So you can go and get this and run it anywhere you like. And you have all the features available at your disposal. Really great way for you to go and leverage this. For example, you can run it on your on-premises environment, or you can run it on your Google Cloud, AWS, wherever you want to run this. You can easily go and run your Kubernetes cluster and leverage all the great features that came with that. So use cases: if you need AKS features, but you're running containers outside of Azure, this is a great service. If you wanted to manage Kubernetes clusters on Azure Stack Hub, again, this is a great service for that situation. And there you go, that's it. We are officially finished. I've got 2 quizzes for you to see if you can remember. What's the fastest way of running a container which gives you the ability to connect your on-premises services through hybrid connection? Give your answer in the chat. So A, container instances; B, VAS for containers; C, service fabric; D, Kubernetes services. And the second quiz is, what do services allow your container to automatically scale based on its workload? Container instance, service fabric, Kubernetes services, or VAS for containers. So what's next? Well, if you wanted to find out more, we have great courses available through our ESI program. So as I've delivered these type of courses, if you want to get the certification as well, again, this is a great course. We also have Microsoft Learn, which has heaps of modules available for free online. You can go and investigate more into any of the services that we've discussed so far as well. So you can be a developer, or you can go through the DevOps engineer path. Either of these is basically having a lot of different available solutions in place. So there you go. So first was C and 2 was D. There are some questions or answers coming in the chat. So the first one was DevOps for containers, and the key was the hybrid connectivity. And the second one was Kubernetes cluster and DevOps for containers. Obviously, Service Fabric Mesh was true as well. So if you want to stay in touch with us, you can find me personally at Twitter. You could just check our dev newsletter, and you could also check or connect with me on LinkedIn. I'm happy to perform all of that. Let's verify our cluster is up and running. If I refresh this, it should be good to go. And our front end is now here, so we can go and have a look at that. So if I come back to my overview section here and grab this URL and bring it here, I should have my application up and running. I could have also accessed this using this public IP address, which was available. So if I come to my services, you can see this one is a load balancer. It's got a public IP address that I have my application available here. So there you go. I can vote, and if I refresh, the data stays the same. If I close the application and open it up again, my data remains here because it's being stored in that Redis cache container, which is running on my Kubernetes cluster. And that's all there is to it for this talk. Thank you so much for being with me for the last hour or so. Hopefully you've enjoyed this talk, and I hope to see you in future conferences and meetups.
Thank you very much. Yes, that was amazing.